All right, on this problem, we're given an equation. We want to find the derivative, dy dx, using implicit differentiation. Kind of a complicated looking equation, so let's take this one step at a time. So kind of term by term, you'll notice in this first one we have a y cubed multiplied by sine of 3x. So we have both x's and y's involved here. We have a multiplication going on in the middle, so we're going to treat this as a product, right? So we're going to need to use the product rule. So I'm going to treat our first function as y cubed and our second function as g of 3x. All right, so using the product rule, let's write it out to get us started. It's going to be f prime, the derivative of one of these, times the other, plus leave the first function alone, multiply by the derivative of the second. So now that we have kind of a plan in place, let's go ahead and try to execute this plan. So first off, let's take a look. We want to take the derivative of y cubed. So we're going to use the power rule. We're going to get 3y to the second power, right? Bring the exponent down, reduce the exponent by 1. But we also have to be careful because we're trying to find dy dx, the derivative of y with respect to x. Whenever our variable is a y that we're taking the derivative with, next to this we also have to multiply by dy dx. So make sure you include that whenever your variable is a y and you're taking a derivative. Next, we're supposed to multiply that by g. Well, I said g was sine of 3x, so that's basically just copying that down. Next, our product rule says we want to copy down f, which in our case was that y cubed, and then multiply that by the derivative of g. So g was sine of 3x. The derivative, in this case, we're going to have to use the chain rule because we have an outer function, the sine function, and an inner function, this 3x, is not a simple x or a y in there. All right, so one step at a time. First thing you want to do is you want to take the derivative of the outer function. So the derivative of sine is going to be cosine. Then we leave the inner function alone. And then we multiply by the derivative of the inner function. So the derivative of 3x is going to be 3. In this case, we took the derivative of 3x. We didn't have a y there, right? Because our variable was an x. So we don't include a dy dx next to that. All right, next, what we want to do is move on to this 8x squared. Think about taking its derivative. Well, again, that's going to be a power rule, right? We're going to bring the exponent down. 2 multiplied by the number in front is going to make 16. X to the 2 minus 1 power is going to give us a 1 for our new exponent there, but we don't really write that usually. We don't include a dy dx because remember our variable was x. Next, let's move on to negative y to the 4th power. So in this case, another power rule, which is kind of nice. We're going to bring along the subtraction. The 4 comes down, reduce the exponent by 1. But this time, remember, y was our variable, so don't forget dy dx goes next to this. And then finally, over on the right-hand side, we have a negative 5. Well, that's a constant. The derivative of a constant is going to be 0. All right, from here, you'll notice I've tried to highlight exactly where the dy dx's are. There's reason for that. We want to have those all on one side, and everything that doesn't have a dy dx, thinking about term by term basically, is going to go to the other side. So in our case, terms that don't have dy dx's are going to be that second term, the y cubed times cosine of 3x times 3. So we're going to subtract that, move it to the other side. Do it to both sides. And then we also have this term with the plus 16x. We're going to go ahead and subtract 16x from both sides as well. All right, where that'll leave us is these will get to cancel, right? One's positive, one's negative. These will get to cancel. One's positive, one's negative. And then let's go ahead and copy down everything that's left on the left-hand side. So I see it as we have 3y squared. I'm going to go ahead and move the sine of 3x out in front. And then dy dx for that first term. And then we also have that minus 4y cubed that had a dy dx with it. All right, so that's what was left on the left-hand side. On the right-hand side, a lot of times we'll write this as negative, move the 3 out, y cubed cosine of 3x, minus 16x. All right, hopefully that makes sense. All I did there was I moved this out in front, and we had 0 minus each one of those terms, so that's why the 0 kind of went away. All right. As you'll notice is kind of the pattern on a lot of these. After you get all the dy dx's on one side and everything that doesn't have one to the other side, what we're going to do next is go ahead and say, well, that dy dx is something in common for each of those terms on the left-hand side. All right, so if we factor that one common factor out of each one of those terms, and it's not the greatest common factor, but that's okay, we're going to be left with, what, 3y squared times sine of 3x minus 4y cubed on the left-hand side, and negative 3y cubed times cosine of 3x minus 16x over on the right-hand side. All right, so at this point we've set ourselves up that we have dy dx multiplied by everything else on the left-hand side, that big set of parentheses. So to isolate the dy dx, we're going to have to divide both sides by that big set of parentheses. So divide both sides by 3y squared sine of 3x minus 4y cubed. Same thing left side and right side. I'm trying to write this quickly, but there's a lot to write. All right, so on the left-hand side, same thing as a factor in the numerator and the denominator. So those will simplify down and cancel out. And that'll leave us with dy dx on the left-hand side. And it's still kind of a mess on the right-hand side, but that's okay. We can't really do a lot of simplifying down over there. In fact, I don't think we can do any simplifying down because we don't have common factors between terms in the numerator to factor out. We do have a y squared, I guess, in common for each of those terms in the denominator, but that's not going to do us much good. So there's our derivative. Hope this helps out as you're working on implicit differentiation, understanding this process. This was kind of a complicated one, I do have to admit, because we did have to use the product rule. We had to use the chain rule. We had some trig functions involved. But hopefully the process itself makes pretty good sense. It's not that bad, but you do have to take your time. I really strongly suggest when one of these rules comes up, kind of write out what the rule is, such as what I did with the product rule kind of at the beginning. Then it makes it more of like a fill-in problem, right? Where you just have to say what goes in f prime spot, what goes in g spot, what goes in g prime spot. So I hope this helps out. Good luck as you're working through implicit differentiation.